Well, here's what a bunch of you had. You had x cubed minus 11 over 2x squared plus 11x minus 15 over 2 is equal to 0. Nothing wrong with that, but you didn't answer the question. What did it say? They wanted integer coefficients. So you got to go one step further. You got to get rid of your fractions by multiplying both sides by 2. And then you got your answer. So that you have minus 2x squared plus 10x minus 12 equals 0. Questions? Now a couple of you got a couple of your coefficients, 2 at a time or 3 at a time. You got something a little wrong with that. What I'd like to do with that is most everybody got things pretty well. A couple of you got messed up on that. I'd like to deal with that on an individual basis and show you where you went wrong. I think you know what 2 at a time is, what 3 at a time is. You just did a product wrong somewhere in there, or you added wrong. Okay? Any others on this? All set on that. Not off the press. So that's radical 2. So when I convert that, it is radical 2 cis 1 or 45 to the 1/3 power. And the question is this radical 2 to the 1/3 power when I employed de Moivre's theorem. Okay? I covered that yesterday. Radical 2 we changed to what? 2 to the 1/2. So you got 2 to the 1/2 to the 1/3, and then what do you do with exponents? Multiply it. For instance, 2 to the square root of 2 is 2 to the 1/2. Cube root of 2 is 2 to the 1/3. Okay. Any others on this front side? Cruising. 2. You got negative 30. You got it? It's the 180, right?
Yeah.
Okay, you got to remember the 180 is on the negative x-axis, so the angle is 180, not 0. That's the one where we make our most mistakes, on ones that I give that are like number 2. The other ones we tend to do fairly well on, but when there's no reference triangle, over the years, that's the ones we get the problems with. All set on the front side? Okay, then on the back side, there was a couple of those that you... Number 3 actually sets up number 4 for you. Okay? We've got x cubed plus 1 times x cubed minus 64 is equal to 0. And we want to solve this by de Moivre's theorem. All right? When you got the product of 2 factors equal to the first one, you got x cubed equals negative 1. X then is the cube root of negative 1 plus 0i. Remember that we represented negative 1 as theorem. If there is some way in the problem I can get x equals. Now if you multiply that out, you're going to have an x to the 6th term minus 63x to the 3rd minus 64. And there's no way that I can just do a simple solution and get x equals and use.
So you do them separately.
Do them separately. Okay? On this one right here, we've got to change to trig form now. What's that going to be in trig form, Susan? Four.
Yeah, because it's negative 1.
Yeah. Okay, so using de Moivre's theorem, it's then 1 to 1/3 cis 1/3 of 180, which is 1 cis 60, and then what's the angle we have?
120.
120. Now notice, we're doing nothing with the other factor. We're just taking care of that factor, getting it done. So I got 1 cis, I got to add 120 to 60, which is 1 cis 180. rectangular form, and I have that on the answer key for you. Are you all set on those?
Yep.
All set on that? And then, once I'm done with that, then I can do the second factor. X cubed equals 64, or cis 120, and the third one is,
Or 60/40.
okay. And then you can convert those to rectangular form, and I got that down for you. All right? See, when I got it in factored form like that, then it becomes real easy to get it x equals, and once it's x minus 8 is equal to 0, that's a trinomial. So it could factor. If it does, it's going to be x cubed and x cubed. Factors of 8 that subtract and give us 7 are
1 and 8.
okay, positive 1. 6 answers here. But the key on a problem like this, now this is, earlier this year we solved equations like this using the rational root theorem, didn't we? Now here, we're solving the same type of an equation, but instead of using the rational root theorem, we're using de Moivre's theorem. Sometimes the rational root theorem works where de Moivre's doesn't. Other times de Moivre's works where the rational root doesn't. So there are two different techniques. Sometimes they can work in the same problem, sometimes they can't. Okay? Any other question on the homework? All set on it? All right, now, I have one more ditto for you. Now on Friday I'm going to give you a quiz, right? And so what I've got is I have a ditto for you that's kind of reviewing So, soccer team is when? Tuesday night? That polar is the same as trig. They use both descriptions of what it is that we're doing, and it depends on the textbook that you're in. And I said polar on here because our last textbook we did was polar. But just cross that and make that trig. So I'm asking you, so what we need to know for Friday is you got to be able to take the complex number in rectangular form, change it to trig form. The second part, you got to be able to take a complex number that's in trig form, change it to rectangular form. Number 3, you got to be able to take a complex number and employ de Moivre's theorem when your exponent is an integer. Remember, if you want to change in, excuse me, hang in here. If I want to change into degrees, remember that pi radians is the same as 180 degrees, so just simply replace pi with 180 over 2 and reduce it. Same thing here, 3 times 180 over 2, reduce it, 270. Or like this one, 5 pi over 4, it's 5 times 180 over 4. Or 5 times 45 would be 225. So if I want to change, all set on what it is that you got to do. I'll answer any questions you have tomorrow on this, and we're ready to move on. Okay?
This is fun.
Okay. In functions in doing different things. For instance, in calc right now, we're doing a thing in my calculus class right now, which is on, it's called the chain rule. And well, I'm not going to just use just x, and I'll tell you why. Because sometimes we talk about functions using different letters, so it's not always in an ordered pair, there is one and only one second element. Is a function by the definition. This one is not. And the reason it is this, if I, for instance, let x equal a 4, let's just take a simple number. If x is equal to 4, I get 4 is equal to y squared. If I solve, I get that y is equal to plus or minus 2. I get two different y values. So, the same x value. Let's look at the graphs of each, and that will help you a little bit. Y equals x squared, how does... And I get the ordered pair of negative 2 comma 4. That satisfies the definition. For each x, I only got one y. Where here, for this x, I got two y's. Okay, so it's okay here to have the same y for different x's. It's not okay to have the same x and different y's. That violates the definition. What does y equal x squared look like?
Like this.
How?
Like this.
Okay. It's a parabola which looks like this, right? How does x equals y squared? It's on the side. So that is okay. This is not, and that's where you come in, Ryan. What's the test?
If you can draw a line and just hit one point, then it is a function.
Okay, what kind of a line? Vertical. Is what we refer to as the vertical line test. Remember that? That up when we took an actual example, but if I have the graph, all I got to do is have vertical line test and check it out. Now, let's look at notations. When we have a function, okay, when in your book you're looking, okay, I cannot use that notation on x equals y squared because that is not a function. So the notation is giving you some information. All it says is that